All right, so example 2 is an example that you should have tried. So right now you should be comparing your answers to mine. So we have this rocket, it launched, and it follows a path according to this equation right here. You can see that it's written standard form. It asks, when would the rocket reach its maximum height? Now these words right there are the key that we're going to be looking for the vertex. And I'm going to work this because you've already done this. So I want the vertex, so I'm going to use, because it's in standard form, that x is equal to negative b over 2a. So the opposite of b is going to be negative 1600 divided by 2 times negative 16, so negative 32. So the axis of symmetry is going to be x is 50. So that means my vertex has an x value of 50, and I just now need to calculate to see what h is going to be equal to. So plugging my 50 into my equation, so negative 16 times 50 squared plus 1600 times 50. And that will give me, using the calculator, 40,000 for my answer. So that happens, my vertex then was 50 and 40,000. So the question asks, when will it reach its maximum height? And what will the height be? So the height is 40,000 feet in 50 seconds. And you can kind of get those units right up there by looking at your problem. So the next question is, when will the rocket return to the ground? So let's try and draw a picture of it right here. First thing we'd like to know is what happens at the origin, or what happens at 0. And if I plug a 0 in for t, and this is t, this is h. If I plug a 0 in for t, I get 0 plus 0 is 0. So my y-intercept 0, 0. We know that it's going to look like a parabola, and that it is going to hit its vertex in 50 seconds, and that's going to be 40,000. So our picture, if we set it up here to sketch it, looks like this. So we want to figure out, when does it hit the ground again right here. And it's pretty easy to do. We're just going to use symmetry. So if it's 50 from here to here, then that means it's also 50 from there to there. And so I'm going to have 50 plus 50, and this is going to end up being 100. So when will the rocket return to the ground? In 100 seconds. We'll skip example 3. Problem number 11 is like that on your homework, and if you're interested, I'll show you how to do that. In example 4, we have a gardener digging a rectangular garden and putting a wire fence along the edge to keep the animals from eating his plants. He has only 20 meters of fence materials available. He'd like to have the maximum amount of area. So we want to maximize the area possible. Does it matter how wide he makes his garden? Well, first we'll kind of draw a little rectangle, and it said if he makes it 3 feet wide, how many square feet would he enclose? So if he made it 3 feet, we know he has, or 3 meters. Well, that's not going to match, does it? So we'll call this feet. So the question is, how much does he have here and here? So how many square feet would he enclose? Well, this is 3, this is 3. I know that I have a total of 20. So if I've used up 6, that leaves me with 14. So if I split that in half, this is going to be 7 and 7. So area is length times width. So I'm coming up with 21 square feet in that. All right, so we're going to do something similar, except we're going to come over here and we're going to do it in terms of x. And I'll call this y for temporarily. So I know that, this is x, this is y. I know that 2x plus 2y, so these 2 x's plus these 2 y's have got to add up to 20 feet. What I want to do now is figure an expression for y in terms of x. So I'm going to solve for y in terms of x. So subtract 2x. So that's 20 subtract 2x. And then this has a 2 times in front of it. So to get rid of that, I'm going to divide by 2. And I get that y is equal to 10 minus x. So I'm going to put right here that this is going to be 10 minus x. So now, when I figure out my area, the area, which is length times width, is going to be x times 10 minus x. So that's going to be my equation for the area, which I want to maximize. Now, you perhaps could get your answers from here, but I'm going to go ahead and distribute and put it in standard form. So I'm going to have that a is equal to 10x minus x squared. So that's a negative x squared plus 10x. All right, so now what I want to do, am I ready to, oh, I'm not ready for the vertex yet. We'll wait for that. All right, so use this function to calculate the area. So your choice, you want to calculate it if x is equal to 5. I can either plug it in here or here. Either place, I prefer here. So I'm going to say that the area is equal to 5 times 10 minus 5. And that's going to be 5 times 5, which is 25 square feet. If I do a 6, I'm going to again plug it in up here. I'm going to have that the area is equal to 6 times 10 minus 6. So 6 times 4 is 24 square feet. So far we've done it for 3, we've done it for 5, we've done it for 6, and you can see at this point that 5 appears to be the largest area that it is the largest area that we found. So is it the largest area? So in order to prove it, we're going to have to find the vertex of this function. And again, you can choose to use the factored form, or you can choose to use the standard form. So let's use standard form. And I will say then that I need to find the axis of symmetry. So x is equal to negative b over 2a. So the opposite of b is going to be negative 10 over 2 times negative 1 is negative 2. So x is equal to 5, which we've already found right here. So x is 5. And when I plug the 5 back into my equation, either one of them, I'm going to get 25. So my vertex is going to be 5, 25. So just a quick sketch of that graph. Again,